This is going on page 26 when we are done. This is factoring polynomials review in all caps. So that implies that this is not brand new to you because it is not brand new to you. Not only is it not brand new to you, but it was in the summer assignment. It's in the prerequisite skills for AP Pre-Cal. So we should be able to do it, but I still want to review you so we can talk about some things. So I'm going to go kind of quickly. If you got questions, you need to make sure you ask the questions and you stop me, or I'm just going to assume we got it. I'm going to keep on going. All right, so we're going to start with GCF, which is definitely old business, and that stands for greatest common factor. Now, sometimes what y'all do is you find the common factor and not the greatest common factor. What I mean by that is this. If you look at number 1, is 2 a common factor of those two terms? Are they both divisible by 2? The numbers themselves? Yes, they are. Is that your greatest common factor? No, and there are times when the common factor is maybe good enough, but not when we're actually straight up factoring, okay, when this is like factor it all the way. So the easiest way when you have coefficients and variables is just to look at them separately. So of these two numbers, 24 and 54, what's the greatest number I can factor out? 6, good. 6, and then how many y's can I take out? 3. So that leaves me with 4y minus 9. Yes? Piece of cake. You should be able to do this stuff in your sleep. Now on number 2, can I factor out a number? 17 is a prime number, right? But does it go into 51? It does. So we can take out 17. How many A's? 3. How many B's? 4. Okay, so that leaves me with, what's 51 divided by 17? 3. 3a to the 5th plus b. Got to be able to multiply and divide your numbers and not be afraid of it. So GCF, just a little reminder of what it is. Don't ignore it. That's the first thing you always want to look at when you're factoring, because sometimes it makes your even though maybe you could factor it without that, it'll make it easier if you actually factor out a GCF if you have one. Okay? And sometimes you can't go any farther if you don't. All right, now we're going to talk about difference of squares, which comes up a lot. Your perfect squares would be like 1, 4, 9, 16, 25, 36, so forth and so on, right? Here is your rule for factoring a difference of squares. First thing is, in any of these, is you have to be able to identify that that is what you have. So if I have something that is in the form of a squared minus b squared, that is what makes it a difference of squares. I'm subtracting two perfect squares, whether they're variables, numbers, whatever they are. So when I do that, it is just a plus b times a minus b. It's very simple to factor, and it actually kind of comes up a lot. So let me start you off with one that's not even on here, since those all have like extra stuff in there. If I just have x squared minus 49, I'm subtracting. X is a perfect square, 49 is a perfect square. So I know that that's going to give me, I'm just going to have an x plus 7, an x minus 7, and it's that easy. Okay, make sense? So it's a super simple one, but if you don't identify it as that, then you can't, figure out what the heck you're supposed to be doing. Alrighty, so then here, 36w squared is a perfect square, and so is 25. So I'm going to have two binomials. What's the square root of 36w squared? 6w, good. And the square root of 25 is 5. So I get 6w plus 5, 6w minus 5. Okay, easy enough? All right, so you do 4. glad to see some of you actually writing stuff. Usually people just completely freeze on this. Is taking the square root of a fraction difficult? It's not. You take the square root of the numerator, the square root of the denominator. What's the square root of 1? 1. What's the square root of 144? 12. So this first term is 1 over 12 in both of them. And then when you take the square root of variables with exponents, if they're all even, you just divide them by 2. So this will be 1/12 plus r cubed s squared and 1/12 minus r cubed s squared. I will tell you that we will come across this type of thing more than we do that last one, but that doesn't mean that stuff like that doesn't show up, right? So it's usually a little bit simpler. Notice what we don't have. We don't have a sum of squares. If this was x squared plus 49, can't factor it, okay? But when we move on to cubes, we can. We have a sum and difference of cubes, right? That's what this looks like here. Well, first of all, let's talk about perfect cubes. Perfect cubes could be 1, 8, 27, 64, 125, 216. We should at least be able to identify those up through 6. We have a sum and difference of cubes. Now, this we need to know how to do. We need this skill. It does not come up as much as difference of squares, which might sound like a good thing, but if it doesn't come up a lot, then we're not practicing it a lot, right? So we have to make sure we have a way of accessing it in our files in our brain for when we actually need it. So I'm going to show you the process, both of them at the same time, because I want you to see how much they are the same, so you're not looking at this as two different things that you have to remember, okay? So we have sum of cubes would be a cubed plus b cubed. Difference would be a cubed minus b cubed. Okay? That's what they look like. For both of these, when you factor them, you're going to get a binomial and a trinomial. And the actual stuff that goes in there, the numbers and the variables, is the exact same pattern. What changes are the signs, okay? So we'll talk about the signs last. When I want to come up with this binomial, kind of just like what we did for the squares, I'm going to take the cube root of a cubed, so that gives me a, the cube root of b cubed, and that gives me b. That's true for both of them, so fill it in for both of them. Then, when we move to the trinomial part, I'm going to take this first one, which is a, and I square it, so I get a squared. Then my middle term, I multiply these two together, so I get a times b. Then the last term, I square b, so that is b squared. And the same thing happens here. That's a fairly simple pattern. So if you actually learn it and practice it, it's something that you will be able to access from your memory. Now, the signs that go in there. Something that helps you with this is SOAP. Anybody ever heard of SOAP when you're factoring this? All right, so write down SOAP over here like this. This stands for same, opposite, always, positive. Same, opposite, always positive. SOAP. So think of your sum and difference of cubes. A bar of soap's not really a cube. It's a prism, but you can pretend. Think of soap. All right, so what that means is this. This is the sum of cubes. That's a plus sign. So my signs are the same, opposite, always positive. That's the way they go in there. When it's the difference, same, so it's minus, opposite, always positive. It doesn't matter what the sign is on the numbers themselves. Like if, I don't know. So let's say this was minus, well, we'll do it when we do it down here, never mind. I'm thinking about the weird things that people do. I'll talk about it on the first one that we do, but for this difference. Okay, everybody good with all this? Questions? Okay, so let's practice this then. we've got we have a sum of cubes here, so I'm going to have a binomial and a trinomial. The cube root of h cubed is h. The cube root of 125 is what? 5. Okay? So h and 5. Yes? Then I square h, and I get h squared. Then I multiply those two together, and I get 5h. And then I square 5 and get 25. I'm going to worry about the numbers and variables first, then I'll worry about the signs. Okay? So this was sum, so this is plus, so this is same, opposite, always positive. Make sense? What questions we got? All right. Let's look at 8. I'm going to have a binomial and a trinomial. What is the cube root of 8f cubed? 2f, right? So this is 2f. Cube root of 27? 3. Okay? See if you can fill in that trinomial. You don't have to do the signs yet, but do the other stuff. So when I square 2f, I get 4f squared. You have to make sure you square the whole thing, right? When I multiply 2f times 3, that gives me 6f. Then I square 3 and I get 9. Everybody good with that? Right, so I squared 2f, got 4f squared, multiplied them together, got 6f, 3 squared is 9. Then I do my signs. This is positive, so it's same, opposite, always positive. Okay. Everybody okay with that? What questions you got? I think it's safest to leave the signs to the very end every time, and I'm going to show you why on 11. Okay, so let's go here. Now this is the difference, so I'm still going to do binomial and trinomial. All of the stuff that is not signs is the same as what we just did. Cube root of x cubed is x. Anybody know what the cube root of 343 is? 7. 7. So then I square it, and I get x squared. This gives me 7x, and this gives me 49. And here's why I think that it's safest to leave your signs to the end, because this is what I see sometimes. I know in the first one it is same, so that's minus. So if I already had that in there, then when you multiply these two together, some people want to make that a negative 7x because that's a negative 7. You with me? You do your stuff, do the pattern, then go back and do the signs and don't worry about them the first time through. Okay, I think that'll alleviate some confusion. So same, opposite, always positive. Okay. What questions do we have? All right, so I wanted to make sure there was one where the variable was second because I see weird things on this sometimes. And let me tell you why you don't want to do it. It's okay that your variable's not first. It's okay that things aren't in standard form. And if you try to force them into that when you do these, sometimes you get your signs backwards. Okay, so we just leave it as it is. First part, second part, right? So the cube root of 125 is 5. Cube root of 8v cubed is 2v, right? And it's okay that the v is second. I don't try and make my v squared term first in this one. That's not the way it works. I take this one, and I square it, and I get 25. Then I multiply them together, and I get 10v. And then I square that. Sorry, I'm going to move this over. 10v. And then I square 2v, and I get 4v squared. Then go back and do your signs. Same, opposite, always positive. Okay. What questions do we have? So we're going to practice, and then when it comes up, we got to make sure that we can dig it out of our brains. All right, everybody okay with that so far? All right. look at this. All right, so now we got trinomials. We're going to start off with the super easy ones, which are just factoring when a is 1. Okay, we should be able to do these in our sleep. Here's some things you want to think about. If it factors, I'm going to factor it into two binomials. Since this is m squared, this is m, and this is m. And before I start worrying about numbers or anything else, I'm going to look at the signs, all right? This is negative. If your last term is negative, then your signs are opposite. That can truly help you figure out the other two numbers. Because now I need two numbers that multiply to give me a negative 30 and combine to give me a negative 13. Are they 3 and 10? No. What's negative 3 times negative 10? What is it? Positive 30. Do I have a positive 30? No. So it is not 3 and 10. What is it? There's other factors of 30, right? 15 and 2. Good. And since this is negative, my bigger number is negative, so this is my negative 15, and that's my 2. So be careful. I use that one on purpose because that happens all the time with that one. And it's not the only combination where that can happen, but make sure that you are thinking, you're not trying to do it too fast, because sometimes when you're good at stuff and it's easy, you zip through it, and that's where the mistakes happen, so be careful there. All right, now 16 is x to the 4th. That does not necessarily make it any more difficult. It's still set up like a quadratic, so this is like squared, and then this is half of it, which is just m. So then I have x to the 4th, then x squared, and then a constant. I'm going to treat it just like a quadratic. I'm going to have two binomials. Instead of x and x, I'm going to have x squared and x squared. That 20 is negative, which tells me my signs are opposite. And then I need two numbers that multiply to give me a negative 20 and combine to give me a negative x squared. Or a negative 1, I'm sorry. 4 and 5, which one's negative? 5. Okay, and then I check to see if I can factor any more. And I can't because I don't have a sum of squares, and that's a difference, but it's not a difference of perfect squares. Okay, everybody okay with all that? All right. Now, where math truly gets made up sometimes, and I'll try to get creative. When a is not 1, you have a coefficient on that squared term, and you can't just start by setting up two little binomials. There are different ways you could have been taught this. The most common way these days, because it does change year to year, is grouping, so that's the way I'm going to do it. If you have another way and you know how to do it and it works for you, knock yourself out, but that's not necessarily always the case. All right, so I'm going to multiply 2 times a negative 7. That gives me a negative 14. I need two numbers that multiply to give me a negative 14. Notice I'm ignoring the negative 7 because of that. They need to multiply to give me a negative 14, combine to give me a negative 13. What would they be? Negative 14 and 1. All right, so then I'm going to split this middle term. So I rewrite this 2d squared, and instead of minus 13d, I'm going to have minus 14d plus d minus 7. Ooh, that's a 9. Don't ask me where that came from. Good Lord. So we're looking d minus 7. There you go. That makes more sense. So if I were to combine these two terms right here, I'm going to get that negative 13d back. Everybody good so far? That look familiar? Okay. Now, here's where I factor by grouping. I have 4 terms. I'm going to group these two together, and I'm going to group these two together. Out of these first two, I can factor out a 2d. That leaves me with d minus 7. Now, in the next two, I can't really factor anything out. And normally we don't factor out a 1, but in this case we do because we need that term there. So this is just a plus 1, and this is d minus 7. And when you're done, like this, you have to make sure, you're not done is what I should say. Some of y'all think you're done here. You are not done. But at this step, these two binomials need to match. If they don't, either you did something wrong or it doesn't factor by grouping, either way. So now my last step here is 2d plus 1 times d minus 7. That is completely factored. Don't stop here, which is what I see a lot of people do. What questions do you have? Are we good? Looking familiar? Knocking some cobwebs off? Yes? Okay. Now, 18. That's got another one that's to the fourth power. Don't let that freak you out and make your brain shut down. All right? If I've got something to the fourth, something squared, and a constant, I treat it just like I did the quadratic. I just have to pay attention to my exponents. So I'm going to multiply the 4 times the 9. That gives me a positive 36. So I need two numbers that multiply to give me a positive 36 and combine to give me a negative 13. What do you think those are? Negative 9 and negative 4. Good. So I'm going to have then 4q to the fourth minus 9q squared minus 4q squared plus 9. And especially when it's to the fourth, watch your exponents, because one thing that happens a lot is people will leave the fourth here, but then these don't end up being squareds, and then they get confused and they're lost in their own work. So everybody with me so far? We split that middle term, right? Double check that it'll go back to what you want. Now we're going to factor by grouping here. Out of these first two terms, the best I can do is a q squared. So q squared, that leaves me with 4q squared minus 9. Now out of these next two, it doesn't look like I can factor anything, but if this first term in the second group is negative, you have to factor that negative out, whether it's a negative number, well, they're all negative numbers, but whether it's a -1 or a negative something else. So this gives me a -1, and then 4q squared minus 9. Okay. Everybody with me? Yes? Okay. Now, I'm not finished, so I need to do q squared minus 1 times 4q squared minus 9. Can I factor this more? Yes. Is this a difference of squares? It is, right? So this can be q plus 1 times q minus 1. Is this a difference of squares? Yes, it is. So this can be 2q plus 3 times 2q minus 3. Now it is completely factored. Okay. What questions you got? Remember that in Delta Math, you can do more than what you absolutely have to do. Some of you may need to practice a lot on some of these because you didn't practice beforehand like you were supposed to. All right, let's look at factoring by grouping. Now, if I have 4 terms, so those were all trinomials, right? If I have 4 terms, then I want to factor by grouping. And it's actually a little bit easier than this because basically we start at this step. Okay, that's because we had to get four terms to do our grouping. We already have 4 terms. So now I already have this here, and then I can just group and group. Out of this first one, I can factor out an h squared. Leaves me with 2h minus 3. What can I factor out of the second one? 3, so plus 3. And that leaves me with a 2h minus 3 also, because remember those have to match, right? Then I will have h squared plus 3 times 2h minus 3. Okay. What questions you got? We good so far? All right. One more grouping one. Well, maybe not. Well, the other ones down here might be too. So out of these two, I can factor out a z squared. That leaves me with z plus 7. What can I factor out of the next two? -5. Yes, it has to be that -5. That way we end up with z plus 7. Then that gives us z squared minus 5 and z plus 7. And on both of these, I can't go any farther. This is a sum of, they're not even squares, so nothing. This is a difference, but it's not squares, so that's the best I can do with the factoring. Okay? Everybody good so far? Awesome. We're going to stop here today, and we will start with solving tomorrow.